All right, let's go ahead and get back into it. Last time we met, we talked about when the test was going to be, right? Okay, so that'll take place, yeah, just during normal class time. Next time I see you, so on Monday. So that's going to cover chapter 2. We've started chapter 3, so the stuff we're seeing now is not going to be on the test, but want to keep going. Sorry, was that a question? Okay, so we started section 3.2 a little bit last time. Basically, it's about, if we're talking about equations or talking about straight lines, graphs of straight lines, can we find the slope? And just to kind of reset, that's always going to come from this calculation here. Basically, if you have 2 points, you're comparing the y values, comparing the x values, and taking that ratio, basically that division there. So the last thing we talked about was, the last example we looked at was a horizontal line, and we found that it has a slope of 0. So this is something we can say that is generally true for any horizontal line you look at. So the slope of any horizontal line is 0, because basically what's going on with this is, if I draw a graph of a horizontal line, you know, one of the ways we talk about slope is rise over run. If you have a function that never rises, you can call the rise 0, and the run, it'll be whatever your difference in x values is. But what about a vertical line? How would I talk about the slope on a vertical line? So we can still talk about rise over run, but where does the 0 go this time? With the rise or with the run? Like when we talk about rise, we're talking about changes in the vertical direction, changes in the y direction. When we talk about run, we're talking about the change in the x direction. So if we have a line that's vertical, one of those two ideas never changes. Which one's that? For a vertical line, the rise does change because I do have movement. I do have changes in the y direction. So it's actually the run that never ever changes. Because of that, we can't really give a number to the slope of a vertical line. The slope of any vertical line is going to be undefined. So slope of a horizontal line is 0. The slope of a vertical line, we can't really even measure it. It's undefined. So let's find a slope. I've given you 2 points here. Remind me how to find slope. So I know we talked about this last time. How do we do that? Yep. So y2, y minus y1 over x2 minus x1. So here are my 2 points that I have. I have 2, 5, and 2, -7. So what's my y1? What's my y2? What's that? 5. Yeah, so again, it doesn't really matter which one you call point 2 and which one you call point 1, as long as you keep those consistent. So this will be 5 minus -7. over what? 2 minus 2. So we have 12 over 0, which is what? Can't simplify that. It's not even a number. So now that I've connected those 2 points, what does this line look like? So this line's vertical, so we can't really find the slope. It's not well defined. So now we've seen one that was horizontal that we saw at the very end of class last time. Now we've seen one that's vertical. How are we doing so far? Okay. So let's graph based on whatever information I gave you. So we know we have a slope of 2, and we have a y-intercept at -4. Let's actually start with the y-intercept. So what does my y-intercept tell me about my graph here? Like, what can I start by doing? What's that?
X is 0.
When x is 0, what does y equal? What's that?
Anything.
No, in this case, we know it's equal to -4. So that's what a y-intercept always happens at x equals 0. And in this case, we're told where that is. So -1, 2, 3, and 4. So we know 1 point on this line. We know the y-intercept. But we can't graph a line with a single point. So where do I go from here? How can I use the other information to help me keep going? Yeah, so what's the slope here? The slope is 2. If it helps, we can say this is 2 over 1, which that's equal to the change in y over change in x, or the rise over the run. Basically, for every 1 unit we go to the right, we have to go 2 units up. So I think my next point will be here. So let's actually give a location to that point. If that y-intercept is at 0, -4, where is this point if we got there by going right 1 and up 2? 1, -2. So we increase the x value by 1, so we have to increase the y value by 2. Now I should be able to graph this whole line. I have 2 points, that's enough. Any questions with how we did that? So how we use the y-intercept, how we use the slope to. Why do we use 0 for the x? Good question. So when we say y-intercept, like what does that mean? Right, but what is a y-intercept is what I'm asking. The second one? So when we say y-intercept, we're basically saying, let me draw you a general, not a straight line, just some generic graph. The y-intercept of this thing that I just drew is right there. So the y-intercept is basically, it's the name we give to wherever a graph crosses the y-axis, that's the y-intercept. So if I know I'm looking at the place where we're crossing the y-axis, what is the x-coordinate of that point right there? Or what's the x-coordinate of any place on this axis? Or do we know? Can we say anything about that? Let me start marking up this graph. Yeah, what are the coordinates of the origin? The origin's on the y-axis. 0, 0. How about this point? What are the coordinates of that point? 0, 4. 0, 2. If I know I'm looking at a point on the y-axis, it must have an x-coordinate of 0. That's why we're saying that if we're saying the y-intercept is at -4, we're flatly giving you the y-coordinate. But by calling it the y-intercept, we're also implying that the x-coordinate is 0. Good question. What else? All right, moving on. What are the slope and y-intercept here? So how do I find that out? Let's graph it first. So now I'm giving you the equation. How do we get the graph from here? So let's actually start by getting the y-intercept. If we know we're looking for the y-intercept, then what do we know about that point? X has to be 0. So in order to find the y-intercept, I can do this. I can say that x equals 0, and then figure out what's true about y. So y equals 2/3 times 0 plus 1, or y equals 1. So the y-intercept, I think we can say, is at 0, 1. Any questions about how we located that point? Okay, so if I'm going to graph a line, I really should get a second point. I need a second point. But how can I get a second point? How we got y equals 1? So first of all, so we chose x equals 0. Why did we make that choice? We're trying to find the y-intercept. So in reality, I just need to find 2 points, but we might as well find the x-intercept. So if we're saying x equals 0, and we know basically this equation tells us how x and y are related, that means I can, all right, if x equals 0, I can plug 0 in for x, and then do the calculations to figure out what y is equal to. So 2/3 times 0 is 0, plus 1 is 1.
Thank you.
Of course. So I need a second point. So let's do this. Let's just pick an x value and find the y value that goes along with it. You all pick. What's a good x value? Anything you want. 3 sounds great. I'm sorry. I heard 2 as well. 3 slightly ahead. So if x equals 3, then how do I find the y value that goes with it? Y equals 2/3 times 3 plus 1. What is 2/3 of 3? 6 over 3 plus 1. 2 plus 1. 3. So here's the second point I found out. 3, 3. So if I graph that, 1, 2, 3. So there's a second point at 3, 3. That's a good graph. So now I can make the full graph.
You just use the equation. I mean, like, you could use the equation to help check it. You use the equation to just do that rather than.
You can.
Okay.
I don't think everyone here has seen that. So, but we'll get to that next. So we know that the y-intercept is at 0, 1. Now that I have the graph, can I find the slope from it? So in pretty much every other case, how have we calculated that slope? Go back and look at it. So if we're looking at slope, we can pretty much always calculate it using that y2 minus y1 over x2 minus x1. So I can do the same thing here. But what do all these values stand for? What are my y2 and y1 going to be? So 3 minus 1, good. Over what? 3 minus 0. So this becomes 3 minus 1, which is 2, over 3 minus 0, which is 3. So the slope is equal to 2/3. Questions there? Go ahead.
So in order to get the second pointer, we can assume any number?
Yeah.
X.
So I heard x equals 2. We only need 2 points to make a line, but if I found another point, it should be on this graph, right? So if x equals 2, y is equal to 2/3 times 2 plus 1, 4 over 3 plus 1, that'll be 7 over 3, which I think is like 2 1/3. So x equals 2, y equals 2 and a little bit more. But yeah, so when I asked for a second x value, it does not matter what the second x value we choose is. That's not 3. 2, 7 over 3. What's that? Well, let's find out. Pick one. -4 sounds good. If x equals -4, it might look like I'm lying to you because I can't freehand draw a graph very straight, but it should still be close. If x equals -4, y equals 2/3 times -4 plus 1. So -8/3 plus 1. -8/3 plus 3/3. So -5 over 3. So the point -4, -5/3 should be here. So 1, 2, 3, 4, and then a little bit. So between -1 and -2. So -1, -2, and yeah. So this is more about my failure to draw a straight line than that point really should be on the line. So what was that? That was -4, -5 over 3. But yeah, so as long as you give me 2 different x values, we're going to be fine. We're going to get 2 different points. And we can finish the graph of a line. What else? What other questions do you have? All right. So the equation of a line. So we just kind of saw this. Maybe we didn't notice that how all this lined up, but this is one of the ways we can talk about any equation of a line is y equals mx plus b. So m will always stand for the slope of the line. B will always stand for the y coordinate of the y-intercept. So if we go back, what was the slope we found? 2/3? That is not a coincidence that that is what this value is. And where's the y-intercept? It was at +1. So if you're given the equation of a line in that form, y equals mx plus b, the reason that it's also called slope-intercept form is because those are the two pieces of information you can get just by looking at it. Whatever number you're multiplying by x is the slope. Whatever number you're adding to mx is the y-intercept. How are we doing? So another form we'll also use is this standard form, this ax plus by equals c. Not a ton of information you can pull directly off of that, but basically we can use one, we can manipulate one of these to get to the other. So now that we've seen that, I should be able to ask you things like this. We should be able to answer this without having to draw any graphs or do any calculations. What's the slope here? -4/3. Whatever the coefficient of x is, whatever the number is, I'm multiplying by x. And then where's the y-intercept? At 1, so 0,1. So my graph should look like this: y-intercept of 1, and then the slope is -4/3. So down 1, 2, 3, 4. 1, 2, 3. So if you have your equation written like this, where basically, if you get y isolated, you get the slope and the intercept, or slope and the y-intercept, just by looking, if you know what to look for. Questions? What are the slope and the y-intercept here? Sorry. So we don't know. We can find the slope of the y-intercept, but we can't just read it off of the way this is written. But if I can make it look like this, y equals mx plus b, that'll give us the information we want. So how do I get from this 3x plus 2y equals 12 to this other form, this y equals mx plus b? Or in other words, how do we get y isolated? And subtract 3x from both sides. So I get 2y equals negative 3x plus 12. So that was a step in the right direction. What next? What's that? Right, but how is what I'm asking. Divide both sides by 2. So now we have y isolated. What is the right-hand side going to look like? Negative 3 over 2x plus 12 over 2, which is 6. Now can I ask you what the slope of the y-intercept are? Slope is negative 3 over 2. Where's the y-intercept? Y-coordinate is 6. X-coordinate is 0. Yeah. It actually doesn't matter. It could be either one. So let me show you what I mean by you can do either one. So let's start this. We can graph the y-intercept is at 6. 1, 2, 3. And then it sounds like, Kuder, what you're asking is basically this. Do I do the slope like negative 3 over positive 2 or positive 3 over negative 2? Oh, no?
The numerator is 3, right? So
Yep.
3 comes, so how we write this right?
Yep.
0, 6. So
Yep.
are we going to write like this? Now it's going to be 3, minus 2.
Oh, no. The reason I'm writing the y-intercept as in brackets like that is because the y-intercept is a point.
Yeah, I do think that the slope is not a point, right?
The slope is not a point. It's a ratio. It's a single number. So how is the coordinates of this point are 0, 6, but this value of b doesn't give you both coordinates at that point. It just gives you the y coordinate. So that's why b is equal to 6, only 6. So of course, and just a reminder, the reason I'm putting the 0 there, if we're talking about a y-intercept, we can assume that the x-coordinate is 0. Every point on the y-axis has an x-coordinate of 0. All right, so how do I graph the slope negative 3 over 2? I will show you both of these. So what if I go down 3, 1, 2, 3, and to the right 2? So I'm moving negatively in the y direction and positively in the x direction. It actually doesn't matter if I do the exact opposite. So what happens if I go up 3 and so positively in the y direction and then negatively in the x direction? So up 3, left 2. Basically both those other points I drew, not even close. Bless you. So no matter which one of those things you do, you'll wind up with the correct slope, as long as you don't do both.
What is the whole thing? Something negative, or do that to like down 3, left 2?
If you go down 3 and left 2, then basically what you're doing is this. You're doing negative 3 over negative 2, which is actually positive because the negatives cancel out. So that's why I'm saying if you have a negative slope, then you want to move negatively in one direction, but not the other. But yeah, so if we start the y-intercept, if I go down 3, 1, 2, 3, and then left 2, You know, if I were to connect that point with my y-intercept, that would have a positive. What else? How are we doing?
Next one,
Of course.
so the next is right, the y.
The y-axis.
So we know it's 0 and 6.
Mhm.
So 6 we count 1, 2, 3, 4, 5, 6, and
Yeah.
then we mark it.
Yeah.
How do you get that second dot? Right?
The second dot? Good question. How do we get this second point? I didn't label it, so maybe it would help if I labeled it. The coordinates of this point are 2, 3. So the way that I got that came from the slope. The slope is -3/2, right? Which means if I know one point on the line, I can use the slope to like navigate to another. So if I let my rise be -3, I'm going to go down 3 places. And I let my run be +2, I go to the right 2 places. That'll always get you to another point.
So slope is a coordinate.
Slope is not a coordinate. I'm using it to help me find other coordinates. But like, for example, like I'm not saying that 3, -2 is a point. Like, so there's a difference here. Whether we're talking about where a point is or how much I have to move to get to another point. So what does slope mean? So slope is a change in y divided by a change in x. And for this specific line, the change in y divided by the change in x is always going to be -3/2. So I'll write this as deltas as well. So delta y over delta x is equal to -3/2. So basically the bottom of this triangle here, that's like my delta x. How much am I going to allow myself to move in the x direction? 2 in this case, which means my delta y. Now let's do this. Can I solve this equation I wrote down here? How would I get delta y by itself? If I multiply both sides here by delta x, then I'm going to get these cancel, and I get delta y equals -3/2 delta x. So if delta x is 2, then delta y has to be -3/2 times 2. What is -3/2? Or what is -3/2 times 2? Be -6/2 or -3, which that is the change in height from that left point to that right point. From the y-intercept, we went down 3 places and right 2. So that, Serrera, I think you asked like to clarify, like, is the slope coordinates? Not in this, like, the slope has to do with x's and y's, but not in the same way that the coordinates of a point does. Like 0, 6 tells you, all right, how far left and right am I from the origin? And the 6 tells you how far above or below the origin am I. But it's always like the origin is the place you have to start. for a slope, like I don't care where I start. Like, I'll give you an example here. What if I start at 2, 3? Well, the slope is -3/2, so if I go down 3 units and to the right 2, then what point will I get? I will also get y value of 0, x value of 4, so 4, 0. If I want, I can do that again. Down 3 over 2, which will put me where? 6, -3. Or if I want, I can go do this. I can go down 30 and write 20. So it doesn't even have to be -3 and 2 every time. It just has to fit that ratio. As long as the change in y is exactly -1.5 times or -3 over 2 times that change in x. That's the thing that's going to be consistent every time. What else? So let's look at a situation in. So now I'm giving you an equation of a straight line that like has a context. So this equation, P equals 28 plus 2.54W, gives a relationship between the like how much I'm paying every month for my water. That's what capital P stands for. And W is the number of units of water that I use. So when I ask you this question, how much do I pay if I use no water? Basically, I'm implying the value of one of those variables. So I'm either giving you W or P, and we can find the other one. So how much do you pay if you use no water? What value am I giving you in that case? I'm giving you W, right? What does W equal to? W is equal to 0. Oh, don't do that. So for W to equal to 0, P equals 28 plus 2.54 times 0, which is what? 28 plus 0? So the answer to this question is $28. So that's how much you pay just to be like connected to the water supply. What about the next bullet? How much do you pay if you use 30 units of water? So now what value am I giving you? Still W, but now W equals what? 30. So where's this point? P equals 28 plus 2.54 times 30, which is what? So 104.2. So how much money I spent on that is $104.20. So what is the p-intercept in this case, or the y-intercept? It's 28. So what is, and that's a value that we found before. So I know that this point right here is 0.28, and that's on my graph. What does that p-intercept represent? So, oh, go ahead. Your bill payment, not all the time. It's only under like certain conditions. So like under what conditions are you going to pay $28 for water? W0 when you don't use any water. So that's basically what the p-intercept represents, is what happens when that variable W is 0. So when you're not using any water, you're still gonna, your value of P is still gonna be positive. What is the slope here? Or like first, like what's the number? What's the value of the slope? What's that? Well, the slope, it will be, in this case, it'll be delta P over delta W. But from the equation, we can actually write down that number. So what are the 2 points that I gave here? 0.28 and this other point is at 30, 104.2, and then this line joins them. What is the slope of this line? So we could calculate it, but we also, by looking at this equation, it's also available there. So if I write you an equation like this, y equals mx plus b, where does the slope show up in that? .54 is the slope, because it's, what are we multiplying by our like input variable W? In this case, the variables are not x and y, they're W and P, but the slope here is 2.54. But what does that slope mean in this case? Well, it means this, basically, if the change in P divided by the change in W is equal to 2.54, then I can also say this, the change in P is equal to 2.54 times delta W. So how much does 1 unit of water cost under this system? So if I buy a single unit of water, what's my charge? 30.54, how'd you get that? Right, so 1 W becomes 1. So how much more do I pay for 1 unit than I pay for 0? So what is 30.54 minus 28? That should be 2.54. So basically the slope is like, that gives you like the rate of change. For every unit of water you use, you're going to pay $2.54 more. Any more questions about this? Okay. So last thing I want to talk about from this section are lines that are parallel and perpendicular. So let me draw you a picture here. If I draw you a line, and I draw you a line that's parallel to it, let's say the slope of this line right here is 2. What's the slope of the other line? think? Think it's the same? So that's true for parallel lines. If two lines are parallel, their slopes are identical. But what about lines that are perpendicular? So I'll do slope of 2 again. So let's say this one has a slope of 2, but then if I graph one that is at a right angle to it, what's the slope of this other line? -2? Well, it's definitely negative, right? But it doesn't look as steep as the other one. So I think that we're right that if I have a line, let's start with the negative line this time. Does it make sense that the perpendicular line would have to have a positive slope? So there are going to be different signs, but I don't think I can just say that I can change the sign, because what if I made the line really steep? Let's say this has a slope of 10. And then I draw something perpendicular to it. I don't think that has a slope of 10 because it looks pretty shallow. Doesn't look very steep at all. But we're right on the money with the fact that they have to have different signs. So what can we say about them? If two lines are parallel, they have the same slope. So they are identical. If they're perpendicular, they're related in, I've given you 2 ways to talk about the same thing. If I multiply their slopes together, I get -1. Or another way to look at it is one slope is the negative reciprocal of the other. So what did we say? The slope was 2? If we have a slope of 2, what is perpendicular to that? Negative, but not 2. Negative what? -1/2. Because again, 2, we can say that 2 is like 2/1.
If they are perpendicular.
What's that?
If they are perpendicular.
If they're perpendicular, that's what this symbol. That's why I put that symbol there to show that it's perpendicular to the other one. So if we describe 2 lines in this way, we know that, like we can, if we know the slope of one, we can get the other by making whatever connection we have to make. Any questions about this? What's that? Yeah, maybe. There. So let's put it, so I said this slope was 2. And this is a right angle, which means this slope is -1/2. Or I said this slope was 10, right? So what's the slope of this other one? -1/10, -1/10. So flip the fraction and then change the sign. What else? Right, let's do a couple things with this, then we'll put the section away. It's just 2, right? All right, so I have a line with the equation that I'm giving you there. And I have another line which is parallel to it and goes through a different point. So let's organize it this way. I have line 1, which is the known one. And I have line 2, which is, right now we don't know what that equation is. So here's the equation I have for line 1. Y minus 3 equals 4 times x minus 2. They're parallel. So what do I know about how they're connected? They're going to have the same slope. So if I figure out the slope of line 1, I automatically have the slope of line 2. Do I know what the slope of line 1 is? Or do we have to do some stuff to figure that out?
Simplify.
So we can simplify. So y minus 3 equals 4 times x minus 4 times negative 2. Good enough, or we got to keep going? Let's go ahead and isolate y while we're at it. So I get y equals 4x minus 5. So what did that tell us? Slope is 4, which means what? The slope of this thing is 4. So I know they're parallel, so whatever the slope of one of them is has to be the slope of the other. So right now, the only thing that we know for sure about line 2 is that the slope is 4. Do we know anything else about line 2? It contains a specific point. It contains 5, 14. Does that give me enough information to figure out what the equation of the line is? So we can always go back to this, y equals mx plus b. And really, your equation is done as soon as you figure out what m and b stand for. Do I know either m or b right now? M is what? So y equals 4x plus b. What do I need to know to find b? The y and the x kind of go together. Like the x and the y are going to be coordinates of a point on that line. The only point right now that I know is on that line is 5, 14. So I'll write 14 equals 4 times 5 plus b. Now can we figure out b? What's b equal to? We're almost there. It's going to be minus 6. Subtract 20 from both sides, and I get that b is equal to negative 6. So we have the slope, we have m, we have b, so this is y equals 4x minus 6. Any questions here? Yes.
Why wouldn't, or why couldn't it be -5 for B?
Why couldn't what be negative 5?
For B. Like on the other side, how it says 4x minus 5 is the.
Yeah, so
Interchangeable with plus and minus.
the y-intercept of this, of the first line, is negative 5.
Oh,
So, and that's what I'm glad that came up. So let me ask this question. If two lines are parallel, what do we know they have in common? Slope, right? Anything else? The short answer is there's nothing else they have in common. So line 1 had a y-intercept of negative 5. Line 2 has a y-intercept of negative 6. They are not going to be the same. So the only connection we really can make because of the parallel is the slopes. So basically, what do our lines look like? Well, line 1 sort of looks like this. Slope of 4 goes through negative 5 on the y-axis. The other line is just one place lower and has the same slope. Good question. What else? Let's go again. All right, same thing. I'm giving you a line and all the information about it. Line 1 is known. Line 2 is unknown. So I know line 1 has this equation, 2x minus 3y equals 12. And I know they are perpendicular this time. So that's what that little upside down T looking symbol means. If they're perpendicular, then what connection can I draw between the two of them? The slope is going to be that negative reciprocal, right? Do I know what the slope is of line 1? Or do I have to do some stuff to it? What stuff do we have to do? What's that?
Isolate Y.
Isolate y. So yeah, that's the final objective. But how do we start doing that? Subtract 2x from either side. So negative 3y equals negative 2x plus 12. Then divide by negative 3. So I get y equals positive 2/3 x minus 4. So what can I do, or what can we do with what we just found? So this slope right here is 2/3, which means the slope of our unknown line is negative 3/2. So I have the slope, but that's not enough to get the full equation of that line. So what other connection do I have to make? There's one piece of information in here that we haven't used yet. They have the same x-intercept. So if I find the x-intercept on the line I know about, I know that point is contained on the second line too. How do I find an x-intercept? So yeah, we've talked a lot about y-intercepts. When you have a y-intercept, a y-intercept always has an x-coordinate of 0. An x-intercept always has a y-coordinate of 0. So what I can do here is this. I can say that, well, when y equals 0, what happens to the rest of this equation? I'm going to go back to the very original. 2x minus 3 times 0 equals 12. Or 2x equals 12. And x equals 6. So I know that line 2 has a slope of negative 3/2, and it goes to the point 6, 0. So now on the unknown line that I want to find the equation for, I know the slope, and I know a point that it passes through. God bless you. Is that enough to figure out the equation for the whole thing? So remember, if we were going for y equals mx plus b, do I have any of this information yet? What do I know? Y equals 0. So 0 equals, do I know anything else? M is negative 3/2. What's x? 6. So that gives us enough to figure out what b is. So 0 equals negative 18/2 plus b. 0 equals -9 plus b. So what does b equal? All right. So then I have m, I have b. I can put those together and get y equals -3/2 x plus 9. So now we've seen one with with parallel lines, one with perpendicular lines. Any questions so far? Right. That's all I got for that section. Should we take a break? Right. Of course. Let's come back at say 4:15. So the two ways we just talked about were, this slope-intercept form, y equals mx plus b. We also talked about that standard form, ax plus by equals c. I'm going to introduce at least one more here. So I would like to find an equation of a line that has these properties. So slope of -9, y-intercept is 0, 3. How can I use that information to write the equation of a line? So probably the most common form of the equation we'll use is this y equals mx plus b. Do I know any of that information already? What's that? M is -9. That's true. What about b? And b should be 3, right? So we know exactly where the y-intercept is. Whatever the y-coordinate of that, that's what b is of that. That'll be b. So y is equal to -9x plus 3. So we've kind of went the opposite direction here. If you know the slope, if you're looking at the equation of a line in that form, you can get the slope and the y-intercept directly from it. Or in this case, if that's the information I'm giving you, we can write the equation pretty quickly. Any questions on that first one?
So the slope on that one would be -9 for 1.
Yeah. So you have very steep negative line. All right. What can we do with this one? Do we know what m is? Do we know what b is? What's that? So m is equal to 1. Why is b equal to 0? Origins. The origin is where? 0, 0. So yeah, I think in this case we can say that y is equal to x. That's fair. So that slope-intercept form is pretty powerful. We can, if we know that information, we can write that out pretty quickly. So we've done that a couple times. Any questions on either one of those? Okay. What about this one? Now let's go from me showing you a picture. So we can still kind of set the goal the same way, y equals mx plus b. But I'm not really telling you anything. I don't have any like written descriptions of this. can we figure out what the slope is, or can we figure out what the y-intercept is? So what does the y-intercept mean? When we use the phrase y-intercept, what are we talking about? So where does it cross the y-axis? So what are the coordinates to that point right there where that happens? 0, -4. So what does that tell us about either M or B? Let's come back to that. Can we find the slope of this?
Delta y over.
So slope is going to be delta y over delta x. So change in y over change in x. So how can we find, yeah, how do we find those two things out? How do we find those changes? So what I would do from a graph is, I would focus on these points that cross like these lattice points. Those are probably going to be the easiest points to figure out what the slope is. So let's, what's that? We can do y2 minus y1. What are the coordinates at that point? 6, 0. And we'll go furthest. Where's that one? -3, -6. So yes, we can find the slope that way. So y2 minus y1 over x2 minus x1. Let's say this is point 1 and this is point 2. So then our slope would be where? 0 minus -6 over 6 minus -3. 6 over 9, which is 2/3. So we have M. We have that slope. So for now, I can do this. Y equals 2/3 x plus b. How can I find b? What's that? Yeah, it's equal to -4, but how come? So the value of b is always going to be the y coordinate of the y-intercept. So in this case, b is equal to -4. So I think this is the first time we've gone in this direction where I give you the graph and we write the equation from it. Any questions here? Go ahead.
The axis -3 and -6, we took it out, right?
What's that?
The axis -3 and -6.
Yep.
We take it out random.
Are you asking if that was random?
Yeah.
Oh, no, it's not. So these 4 points that I identified here, basically I'm looking for points on this line that cross like where the lines on the grid match up, because I think those are going to be the easiest to read. Like for example, I would have a hard time figuring out exactly what fraction that y value is. So that's why I was encouraging us to only go after those points. But as for like where this is, yeah, now we're counting like how far to the left of the origin, 3 places. How far below, 6 places. What's that? Well, the way we found that point of -3, -6, that comes from basically following the coordinates on the graph. We found the slope by finding the change in y and change in x between -3, -6, and 6, 0. Yeah, so, and just to prove it to you, where are these points? So that's, oh, we already labeled that one 0, -4. Where's this one? 3, -2. If I use those 2 points to find the slope, what should I get? I should get -2 minus -4 over 3 minus 0. So -2 plus 4 over 3, 2/3. So it really does not matter what points you choose. So it's better to choose points that are easy to read. Not necessarily. We could have found the slope first. You can choose whatever 2 points in that line you want. The only reason I'm staying away from like points like this, like what are the coordinates of this point here? X is 5, but what is Y? It's between 0 and -1. But I'd rather not eyeball a fraction if I don't have to. So that's why I'm encouraging, go after those lattice points where the lines on the grid cross each other. What else? Go again? What do we do first this time? Y-intercept? Let's find the slope first. So I just need 2 points to find the slope. So what are 2 good points to choose? 3 negative, I mean, that one's like strongly hinted at. 3, -1's a good place to use. What else? 0, -5. So I think those are good points because those are also lattice points. All the coordinates are whole numbers. Make the math more convenient. So how do I find the slope with those 2 sets of coordinates? Sorry, one more time. Yep, delta y over delta x. But then what are we using for those changes? Yeah, what are we calling y2 and y1? -5 minus what? Yep. Over 0 minus 3. So -4 over -3. 4/3. So that's the slope, which is helpful. Yeah. If it was -5 minus 1, that would be -6. But what we have is minus -1, right? So that's -5 plus 1. Yeah, you're good. So slope is 4/3. What other information do we have to get? B. Do we know what B is? Or do we have to figure it out? In this case, B, we can say B is -5. So one of the points we chose to base our slope on was 0, -5. So that is the y-intercept. So now I can do this, y equals 4/3 x minus 5. So we've done a couple working from graphs now. Any questions on either one of those? Okay. So find the equation of a line. I'm giving you the slope, and I'm giving you a point. So for now, let's do this. We can figure out, if we can figure out what M and B stand for, we'll be done. What's that? I agree with 3, I don't agree with 7. So the slope is 3, that's good. But what does B stand for? The value of y, it's the y-intercept. So when x is equal to 0. But the point I gave you is not that point. So here's the point we have so far. We have, somewhere out here, -1, 7. And I know that through that point, there's a slope of 3. So it looks something like this. But I don't think I know the y-intercept yet. So I can use that y value to figure out the y-intercept, but it is not B. But here's what I can do. I know that m equals 3. The slope is given to us. So you have y equals 3x plus b. How can I use that point, that -1, 7, to figure out what b is? What do the x and y stand for? What was that? So yeah, x and y are the coordinates of a point, or they're the coordinates of any point on this line. But since I only know the coordinates of a single point, that's what I should use. So what do I plug in for y? 7. And for x? -1. So I can use that one known point and the known slope to figure out what the y-intercept is. So I have 7 equals -3 plus b. Add 3 to both sides, and I get that b is equal to 10. So now here's the equation with everything plugged in. Y equals 3x plus 10. So this is the first one, at least in this section, the first one we've looked at where I did not give you the y-intercept. So like the last thing we were able to find. Any questions on how we did this? Let's go again. So another thing I want to show you, another form that we can work with is point slope form. So what does this form look like? So y minus y1 equals m times x minus x1. So where does this thing come from? Something we always talk about is, you know, several times today we brought up, what is slope? It's delta y over delta x. How do I find delta y? Well, it's a change, so I'm going to find two y values and figure out how far apart they are. I'm going to find two x values and figure out how far apart they are. This point slope form basically comes from the slope, except I'm not going to call it, I'm not like y1 and x1, that's like, those are constants, those are not variables. So instead of x2 and y2, what I'm going to do is this. I'm just going to say that they're variable. So let me draw you a picture. Here's a straight line. And I'm going to say that right here, this is like x1 comma y1. That's a point that's not variable. It's just stuck right there. The other point is going to be what I'm going to call xy. That, like I can, so this one right here, it's fixed. It's stuck right here. This other one I can basically move back and forth. But no matter where I move it, like let's say I put it here or here or here, what is the slope from the first point to the second point every time? I don't know exactly what it is, but I know that I can always call it m. So basically, instead of saying that m is equal to y2 minus y1 over x2 minus x1, I'm saying that slope m is equal to y minus y1 over x minus x1. Like I'm still using the ideas of change in x and change in y and dividing those two things to find slope. But basically, there's another form of the equation that we can use that's based on that. But why would we want to? Let's find out. So I want to find the equation of a line with slope negative 2/3 that passes through this point 10, negative 5. So this is kind of like the last one we did. I'm giving you a slope, and I'm also giving you a point that the line goes through, but it's not the y-intercept. So we can't go straight to y equals mx plus b. But what I can do is this. I can plug in x1 and y1, and I already know what the slope is. So in this case, what's the y1 going to be? Negative 5. The slope is going to be negative 2/3. And x1 is going to be 10. So let me do some simplifying. Y plus 5 equals negative 2/3 x minus 10. So this is at least brand new to us. Maybe you've seen it before, but this is another way to write the equation of a line, is like this.
And that would be the answer.
Yeah, so this is in point slope form. So why is it called that? It's called point slope because basically what are the constants that are in this equation? So x1 comma y1, that is the coordinates of any point. Like you can just pick one. Some point that the line goes through. And then what does m stand for? Same thing that it always has in the other form. It's the slope of the line.
So is it just like regular x, y, those are set?
Yeah, the x and y, or sorry, no, the x1 and y1, those are fixed. Like that's the point that I'm calling constant. It's the other x and y without the little subscripts on them. Those are variables. So part of the value of this thing is, if I ask for the equation in this form, I don't care, like this right here can use any points. I don't need the y-intercept. As long as I know any points on this line, I can use this. But let's do this now. Now that we have this, let's isolate y. How would we isolate y from here? Subtract 5 from both sides. If we subtract 5, we get y equals negative 2/3 x, or 2/3 times x minus 10, all minus 5. Can we simplify the right-hand side a little bit? So this gives me negative 2/3 x, negative 2/3 times negative 10. That'll be positive 20/3 minus 5. And 5 we can say is 15/3. So now this all looks like this. Y equals negative 2/3 x plus 5/3. So now that I've done this, this should probably look more familiar. So if I'm looking at this equation, what's the slope? Negative 2/3. And what's the y-intercept? So this right here is y equals mx plus b. If the b stands for, or the b tells you something about the y-intercept, and b is equal to 5/3, what are the coordinates of the y-intercept? 0, 5/3. So that's one thing, and again, this is called slope-intercept form because the slope and the y-intercept are the two pieces of information you can get from that. So one thing I wanted to highlight is that you can use one of those forms to get to the other by isolating y and by simplifying wherever you can. How are we doing? Go ahead.
Can you tell me that when do we use this equation, y minus y1 and the mx?
I'll basically tell you like what form I want it in. So in this case, I didn't ask for it, but like the slide doesn't ask for it, but I wanted to illustrate the new thing that I showed you. But like if I,
So we can use this equation in our previous questions as well.
yeah, like we haven't because I hadn't shown it to you, but you can. The bottom one is slope-intercept. This one right here is point slope. So basically, these are, they're equivalent to each other. I can manipulate one of them to get the other. Where they're different is basically what information you can get just by looking at it. So I mean, we built this from scratch, but here's the information that's kind of contained in here. There's a negative 2/3 multiplied by this x parentheses. That tells me the slope is negative 2/3. What are the 10 and 5 talking about? So this x minus x1, that's basically, this x1 represents the coordinates of a point, or the x-coordinate of a point that's on this line. In this case, that's x equals 10. Same thing with the y minus y1. So since this is plus 5, that tells me that y1 is negative 5. And that was, we chose those values based on the coordinates of the point where we're given. We were told that 10, negative 5 was that's the only point we knew that was on that line at first. How we doing? So I want to find the equation of the horizontal line that passes through negative 1, 5. So what information do we have here? So here are both forms. Here's slope intercept. Here's point slope. And basically, it might be best to choose which one we use. Maybe we should figure out what information we have. So what information have I given you about this line so far? So the X and Y, what are those going to be? So I think we have a point. X1 comma Y1, I'll say, is negative 1, 5. So we know the coordinates of a point, and that point, is that point the y-intercept? It's not. How do we know it's not the y-intercept? So where is the point negative 1, 5? Over here somewhere. Where would that point need to be if it was the y-intercept? It'd have to be 0, 5, right? It would have to have an x-coordinate of 0. So I don't know the y-intercept yet. Do I know anything else about this line? What's that? It's horizontal. So what can I do with that information? I mean, if it's horizontal and I know a point on it, then it should look like this, right? Yeah, the x values don't really matter. Basically, if I choose a point out here and say that x is equal to 7, what's y equal to? Not 0, 5. If it's a horizontal line, then they all have to have the same y value, right? Do we know the slope of this line? Well, we can find it. Slope is equal to delta y over delta x. Y2 minus y1 over x2 minus x1. So y2 minus y1, I'm going to say it's 5 minus 5 over 7 minus negative 1, or 0 over 8, which is 0. Does that look familiar? So one of the things we talked about in the last section is that if you have a horizontal line, there is no change in the y variable ever. So your slope is always going to be 0. So here's what we have. We have slope is equal to 0, and we have, like, this reference point is negative 1, 5. So from those two pieces of information, I think we can write the equation, or write a version of it. So based on what we have, I'm going to do point slope form. So y minus 5 is equal to 0 times x minus negative 1. So y minus 5 equals 0 times x plus 1. What happens on the right-hand side here? It's not x plus 1. I mean, the final result is going to be 0. 0 times anything is going to be 0. So how do I solve for y from here? Add 5, you get y equals 5. Any questions so far? So I mean, it's kind of hard to talk about when the slope is 0. But like, how did we find either one of these equations? I mean, we started from point slope form, but then by the end, I think this is more of the slope intercept form because we actually got y by itself. We isolated y. Any other questions about this? All right, moving on. What's left? Let me see. All right. Now I want to find the equation of a line that goes through these 2 points. So let me remind you of the 2 forms we have. So y equals mx plus b. Y minus y1 equals m times x minus x1. And let's take stock of what information we have. So what do we know right now? What's that? We have 2 points, so I can call either one of them x1, y1. So we have a choice. So let's just list both the choices. -3, 5, we could use if we wanted to. We could also use 1, -3. So that kind of suggests that we might want to use point slope form because we know 2 points, and either one of them is the y-intercept. But no matter which of these 2 things we use, we have to know the slope. Do we know what the slope is? We don't right now, but could we find it? How do we find slope? Right. So this, if you have 2 points, you can always use this. So what's the numerator going to look like? -3 minus 5. And then what's the denominator look like? 1 minus -3. So our slope is going to be -8 over +4 or -2. So now I think I know everything that I need to know for point slope form. I have the slope and I have a point. And we can write it both ways. Like they're both totally acceptable. So if I use the top point at -3, 5, y minus 5 equals -2 times x minus -3, or y minus -3 is equal to -2 times x minus 1. So when you're using point slope form, you have all kinds of choices about what to use as that x1, y1 point. And in this case, we knew 2 points, so we can use either one of them. So these are both good. Any Any questions on how we got those two equations? How could I get point slope from there? Or not point slope. I have point slope. How could I get the slope intercept form from there? So the y equals mx plus b. So let's just take one of these. Y minus 5 equals negative 2 times x plus 3. How can I make that look like y equals mx plus b? At 5. So yeah, we'd like to isolate y. So y equals negative 2x, or 2 times x plus 3, plus 5. So y is isolated. We have some simplification that has to happen on the right-hand side. So y equals negative 2x minus 6 plus 5. So y equals negative 2x minus 1. So now we have basically 3 different equations that all say that all describe the same line. If you were to graph all 3 of those, you get the same thing. So these two in this box are point slope form. This right here is slope intercept. Question?
How did you come up with positive 5 being B? What does each correspond to?
So positive 5 is not B. Are you talking about like down here in the corner?
Yeah.
So this right here is point slope form, like this is this equation. And one of the things that we can do is convert. So if we have point slope form, we can convert that to slope intercept form. And the way we do that is by getting y by itself and simplifying the other side of the equation. So that plus 5 is what came from, you see it? Okay. What else? I don't think I got all 3 of these. We'll just get that one. All right, I want to find the equation of a line parallel to this one and containing 0, negative 3. So how can I start working that out? What do I know about this line?
The X and Y axis.
What about the x and y axis? So I know that that point is 0, negative 3. Is that on the known line or the unknown line? The one so there's one line that I'm told a bunch of information about. And there's a second line that I'm trying to learn things about. Which one of those two things is 0, negative 3 on?
No.
I think it's on the unknown one. So we want to find the equation of the line parallel to 4x plus 3y equals 6 and containing the point 0, negative 3. So to show that these are different, I think if I plug in 0 for x and -3 for y, I get 0 minus 9. Now that's not equal to 6. So that equation, this equation right here, it is a line, but it doesn't have 0, -3 on it. So right now, the only thing I know about that first line is that its equation is 4x plus 3y equals 6. What do I know about how line 1 and line 2 are related to each other? Same slope. How come? They're parallel. So they're parallel. Therefore, same slope. What is the slope of line 1? What's that? It's not 6. Right now we can't know what it is until we do something else. So what do we need to do to that equation to figure out the slope? What's that? Everything into what? I'm sorry. Oh, we don't need to. I mean, we could do that, but we've done something like this week a few times. So one of the forms we know for a straight line looks like this, right? Y equals mx plus b. If we get y isolated, we should be able to get the slope. So how do we start isolating y? If we divide both sides by 3, then that 4x is still going to be there. So I think we are going to have to divide by 3, but I think we should do something else first. Let's subtract 4x. So that cancels, and I get 3y equals -4x plus 6. Now let's divide by 3. So we get y equals -4/3 x plus 6 divided by 3, which is 2. So now what did we just learn about that line? The slope is not 2. The slope is -4/3. So since this slope is -4/3, so let's actually get both of these. The slope is -4/3. What does the 2 tell us? That's the b, right? So that's the y-intercept is at 0, 2. Does that slope tell us anything about line 2? It has to be the same. The slope of this line is also -4/3. Does that y-intercept of 0, 2 tell us anything about the other line? What's that?
It's on the x-axis.
Well, it's on the y-axis. It's on the y-axis of line 1. But what I'm asking is, like, is there any connection between this point 0, 2? Is there any connection between the y-intercept of the first line and the y-intercept of the second line? Well, the x-coordinates are both going to be 0. That's true. But one thing what I'm trying to emphasize is that if lines are parallel, all you know is that their slopes are connected. You know their slopes are the same. There's nothing else that you can really learn. So here's what we know. We know we have a slope of -4/3. And actually, what does that point tell us? What's that?
And it's just on the line.
It's on what line?
The second line.
Oh yeah, it's on the second line. Okay, yeah. So now we know the slope and we know a point. So how can we write the equation of that line? So we have a couple different ways to do that. Y equals mx plus b, and y minus y1 equals m times x minus x1. We know m, right? Do we know b? Do we know if we know b? Do we know x1 and y1? So we know x1 and y1. So we know everything we need to know about that bottom, the point slope. So let's go ahead and fill that in. So y minus -3 is equal to -4/3 times x minus 0. So y plus 3 is equal to -4/3 x. So I think this is good for point slope form. But what happens if we isolate y? What would that be? If we subtract 3 from both sides, we'll get -4/3 x minus 3. So we didn't realize it, but we did have the y-intercept because 0, -3 is, since the x-coordinate is 0, that is the y-intercept. Any questions about this? All right, we got a few minutes left. Let's do one more and then we'll call it a week. So just like last time, we have a known line and an unknown one. So line 1 is the known one. Line 2 is the one we care about, the one we want to actually figure things out about. So let's start writing down information. What do we know about either one of these two lines? What line does that belong to, the first one or second one? So the first line has the equation x minus 2y equals 5. I agree with that. Good, what else? Where does that point belong? On which one, sorry? Right, that's right. I didn't hear you. So -2, 2 is on the unknown line. Is there anything else that I know? So I do know that line 2 is perpendicular to line 1. So that's a valuable thing to know because that tells me something about, if I get information about line 1, I can use that to tell me information about line 2. So when lines are perpendicular, how are they related to each other? The slope, we know that they're connected to the slope somehow. So before we go any further than that, let's figure out the slope of x minus 2y equals 5. How do I figure out what that slope is? What's that?
Can we do the 1, 2 minus 1, 1?
We can't really do that because we don't know 2 points. Right now, we actually don't know any points on line 1. We could find some, but right now we don't know any. So let's look at what we did last time for line 1. To find the slope, we manipulated it to get it into slope-intercept form. So let's start doing that here. I want to start getting y by itself. So how do I do that? Subtract x from both sides. It's a good first step. So negative 2y is equal to negative x plus 5. Good. Now what? Divide by negative 2. So y is equal to positive 1/2 x minus 5 over 2. So what did we just learn about line number 1? The slope is what? 1/2. So what is the slope on line 2? What was that?
Negative 2.
Negative 2. So the reciprocal and also change the sign. Do we know enough about line 2 to start figuring out what its equation is? So we have a slope and we have a point. So how does that help me figure out an equation? I can do point slope because I don't know the y-intercept this time. But I do know the slope, and I know some point. So let's start filling these things in. Basically, this negative 2, 2, I'm calling this my x1 comma y1. So this becomes y minus 2 equals negative 2 times x minus negative 2. So y minus 2 equals negative 2 times x plus 2. And that is, it's a perfectly valid way to write that equation. That's in point slope form. Any questions about where we ended up here? All right, I think that's the end of that section. Let's go ahead and call it there. So yeah, just last reminder, test is on Monday, in here, in person. If you have any questions about anything at all, let me know. I'll stick around for a bit. Otherwise, I'll see you all Monday.
So that
Okay.
yeah. Also like storage terminology, you use like sort of 7 and slope
Point slope, yeah.
and some of the I don't know if they're doing
Okay.
what they do.
So the reason this is called slope intercept is because these two constants in here, m and b. M stands for the slope. B tells you about the y-intercept. The other one, the
I don't have that already.
okay.
Take it.
Yeah, yeah. So this one's called point slope form because, or let me go to the generic one. YouTube, see ya?
Point slope is?
Yeah, point slope, the M tells you the slope.
Okay, yeah.
So M stands for slope in both.
Yeah.
And then the combination of x1 and y1, that is that's just some point. Any points, yeah, that's a point
Combo
slope.
of x1 and y1?
Yeah, so x1 is the x coordinate of a point,
Mhm.
and y1 is the y coordinate of a point.
Mhm.
So like in this one, the point was 10, negative 5.
Mhm.
So this is y minus negative 5, x minus 10.
So what if we were to use this one, the slope intercept equation here, would it give us the same answer?
So it wouldn't look the same, but so we did this one in point slope form and slope intercept form.
Mm-hmm.
But the way we got there is we took the point slope equation and we did all this algebra to isolate y.
It would give us the same answer, right?
Yeah, so
If I were to,
if I graph this
mm-hmm,
and then I graph that,
mm-hmm.
they'll land right on top of each other.
Okay.
They look totally different
Mm-hmm.
when you look at
Yeah.
their formulas, but they top at the same line.
So if I get a question in an exam, and I can use slope intercept in all the questions, right?
Unless I tell you to give me point slope. So like,
Well,
be careful, be ready to kind of interpret either one of them.
so how do we do that?
How do you do it?
Like, when do I know that I have to use this equation, and when do I know I have
I'll
to
tell you. I'll say, find the equation of this line in point slope form.
Okay, so if it says
Yeah.
just find equation of
Yeah, but like, so the way in my slides, I didn't put that instruction in there. I just made us do both,
Mhm,
so you knew what both looked like. But like you'll see on the homework when you go into my open math,
mhm.
and you'll probably see on the test on Monday, find the equation of this line. Some of them might say nothing, but some of them might say in this specific form.
That's the thing I'm confused. Like, how do I tell when it is slope intercept and point slope?
So let me go to my open math and I'll give you some hard examples. Yeah, was that? Yeah. Mhm. This is 3, I think. Yeah. So right here,
Mhm.
find the equation of the line. Be sure to enter your answer as an equation. Enter the equation in point slope form.
Okay.
So it's like, if I want a specific one, I'll have to tell you point blank. Do it the way I want it. This one right here doesn't say anything.
Mhm.
Just give you the
So
equation.
What does it mean? Like,
Basically, it gives you
Exactly.
more freedom. Like
Okay.
you can choose whatever you like. Point slope form. So I mean, most of these tell you what form to give you the equation in.
so if it is just saying an equation, I can use y
You can-
equals mx plus b.
Yeah, you can use whatever you'd like.
Yeah. Can you go to question number 10 and just repeat it one last time?
Oh, on slides?
Yeah. Because I think 10 and 11 are same. If I get to
They're
know,
similar, yeah.
yeah, if I get to know one, I'll just figure out.
So these lines are parallel. So basically, I have the equation for the first line, so it's 4x plus 3y equals 6. So what we did with that, like in this form, I have no idea what the slope or y-intercept or anything else is. But when I get it to y equals mx plus b form, then I can figure some stuff out more easily. So turn this into y equals negative 4/3 x plus 2.
Mhm.
And now from this form, I know the slope is negative 4/3, right?
Mhm.
And I also know these lines are parallel.
Mhm.
So once I found that slope, I have that
Yeah.
one too.
Yeah.
And then the other piece of information I was given from the start was this point 0, negative 3 is on that line.
Mhm.
So once you have a slope and a point, you have enough to find the equation. And in this case, we ended up doing it both ways. So this right here is point slope form.
Mhm.
Either way, we don't have to do both of them for the test, right?
No, I'm not going to necessarily make you do both.
Yeah. So either way, we just gotta answer this. We find it right.
Yeah,
Right
like
here.
either one of these is correct. So like if I say find me the equation of the line, and that's all I say, either one of these is good. If I say find the equation in slope-intercept form, it really should look like this. Or in point-slope form, it really should look like this. So I get to know the difference between those two, be able to find both. But if I don't specify which one I want,
Monday is for chapter 2, right? Just chapter 2.
yeah, I say, oh yeah, this stuff's later. So this stuff will not be on the test.
For the exams, is it going to be like in person or pen and paper?
Yeah.
That's how it is?
Yep.
One last thing,
Yeah.
so, and it's for future references
Yeah.
as well. So you give out questions exactly how we practice this in the class, right? On the same template, or is it like a brand new question?
Oh, they'll be, yeah, they won't be exactly like this, but
Yeah, I know, you might change a couple of digits or numbers on it, but the formatting of the template, you might say, would be the same.
I don't know if what do you mean by template?
Let's say I get the exact same question, but with a different
Equation.
equation here
Yeah.
and different points here.
Yeah, I mean, I can't promise you it'll be that similar, but
Because look, the only thing I am worried about is a word problem, and because I know with a new word problem, it's going to be a different concept, it's going to be a different approach to get to the solution to the answer, and that is what I have spoken with a couple of students in the class, and they have the same thing. Like,
Yeah.
word problem is
like that's the hardest thing we've done so far.
yeah.
That's why when I was going through word problems, I was trying to focus on like what are the things that are like common
Breaking down
across all these examples.
Yeah.
But really beyond that, like every word problem is going to look a little bit different. But everything I give you is going to hit the same. They're going to be solved in some of the same ways, like figuring out what your variables represent, figuring out like what language suggests multiplication, what language suggests addition or subtraction, things like that. Well, for those mixture problems, like you can kind of organize all of those in similar ways. Like, so if you find a way that works for you to kind of organize those things in like that table form or whatever, that'll pretty much always work.
All right.
But in terms of like, I mean, I could give you a word problem and totally change the wording and still have the math come out the same way. So it's all about
how I interpret it.
yeah, learning how to interpret it is like, that's the important
That's
thing.
the
That's
key.
the difficult thing.
The only reason I'm worried about is because I have to maintain current GPA and current credit hours in my class just to stay, because I'm an international student, right?
Right.
So we have to maintain that, and if we don't, we get kicked out and our status goes off.
I got you.
So
Have you looked at the test review that I posted?
what do you mean?
So I posted this on My Open Math a few days ago.
That
So this-
word's very confusing.
So I mean, this test one review,
Mhm.
have you opened that yet?
No.
Okay. Go look at that as soon as you can. Because like that'll be a good like check of kind of like where your problem areas are, what you understand really well, stuff like that. Tomorrow is the only other day I'm here this week. So I'll be in office hours tomorrow between 11:30 and 1 if you want to talk about anything on there or anything else. We can talk on Friday. It'll be remote.
Mhm.
Just you can send me an email if you want to meet or talk about anything. But I would encourage both of you very heavily to open up this test review and start looking at the things on there.
Okay. I will.
Okay.
Perfect. Thanks so
All
much.
right.
Thank you.
Thanks, guys. I'll see you next week. Yeah. Take care, guys.
Yeah.